Hello everyone, my name is Baixuan Tang, and the title of my paper is Triangle Coordinate Diagram Localization for Academic Literature based on Line Segment Detection in Cloud Computing. And this is my report outline. Firstly, I will introduce the background of this work, and then I will introduce what the triangle coordinate diagram is, and then I will introduce how to localization this diagram in the literature, and then I will show the result of the experiment, and finally the conclusion. As we all know, diagram is an important part of academic literature. As a special non-text data structure in the literature, it can reflect the key research method and conclusion. And at the same time, database providers continue to strengthen the disclosure of visual resource in the literature. It can be predicted that the development and the construction of a visual resource in the paper will further promote the organization and the dissemination of academic knowledge. But compared with the text content in the literature, there are relatively few studies on the diagrams. I think one of the main reasons is in the common academic storage format, PDF is not logically structured. Nowadays, common research on the localization of diagrams is mainly based on the coding of PDF. However, these methods ignore the visual information on the page. And in this paper, we propose a diagrams localization method based on the visual information of academic literature. This method can locate the diagram in the literature stored in the form of image rather than text, so it can have greater applicability and will not be affected by the storage format. And what is triangle coordinate diagram? Well, they usually use three-dimensional percentage coordinate to represent the proportion of element in three-component system to the overall structure. And as a kind of structural information image, three sides of triangle represent three different elements. Three vertices represent three origins, and the three-dimensional coordinate of a point represent the propagation of each component in the element. And the triangle coordinate diagram can be used as a classificational diagram by classifying each element according to its component proportion. And the contribution of this paper are as follows. First, a line segment merging method is proposed. And second, a method to locate the triangle coordinate diagrams according to the detected line segments is proposed. And then I will introduce how to localization. So firstly, we need to denoise the image. According to the value of red channel R, green channel G, and blue channel B of the image, the original image is converted into gallery image I by using this formula. When all pixels of the image are transformed into gallery image by gallery operation, Gaussian blue formula is used to convert the gallery image I and the Gaussian kernel. The Gaussian blue formula is as follows. In order to better detect the line segment in the image, in the next step, Superoperator filtering is also needed for the image. and in practice there are a large of a number of transverse straight line in the lignature in the image. Therefore, sober transverse conversion kernel is used here to convert the image. In this way, we can get the image Y after filtering out the transverse edge. The formula is as follows. The result is following. And in this step, line segment detection will be performed on the lignature image to obtain the line segment set. And we use LSD to detect line segment. The main process is as follows. Firstly, we calculate the gradient angle and the gradient of each pixel in the image. The formula is as follows. And second, the direction of the pixel is combined into direction of the line area. The pixel is filtered by judging the direction of pixel and the direction of the line area. We choose an unselected pixel as the seed point to judge the pixel. The other pixel whose difference between gradient angles and the region angles is less than the threshold is added to the line support domain. Every time a new pixel is added to the area, the region angle of the whole line area is updated. The angle formula of the area is as follows. The diffused region is filled by a right angle, and an external right angle contains all pixels in the region, which is constructed. The mean axis angle of the rectangle is calculated, and the mean axis angle is set as the angle of the line segment to be extracted. And then we use NFA formula to verify the right angle R and to calculate whether the right angle arm meets the threshold. If not, ignore it. If yes, express the rectangle record as a detected line. The formula is as follows. And this is the formula of B. And finally, we go back to step 2. Find the next seed point, spread the rest of the image until traverse the whole image, and get the original line segment set of the image. The results are as following. LSD has excellent ability to detect line segments. However, a single line segment in the image lignature may be detected as a multiple line, and which will have a negative impact on the locating the tab determination of the diagram. Therefore, after line segment detection, it is necessary to merge the line segments according to the certain rules. To delete the redundant segments and connect the segments that are wrongly segmented. In this paper, according to the specific situation of the lignature, some thresholds are present when using this method to identify the diagrams in the other lignature. The threshold needed to be adjusted according to the situation. First of all, set the line segment in merging threshold and slope merging threshold. The threshold value can be set according to the page set or according to the experience. Then, the redundant segments are merged. And firstly, redundant line segments with similar lines and position are merged. The method is as follows. Judge whether there are two pairs of endpoints in two line segments, and the distance between the two pairs of endpoints is less than the endpoints merging threshold. If there is a group of line segments that meet the conditions, merge them. And according to the formula, the center point of each part of the endpoint is taken as the endpoint of the merged line segment. A merged line segment is generated, and the two original line segments are deleted. The end coordinate xy formula of merging line segment is as follows. After that, merge the redundant segment with lines difference. The methods are as follows. Judge whether the slope difference of two line segments is less than the slope threshold, and whether the maximum distance between the two ends of the shorter line segment and the longer line segment is less than the point line merging threshold. If the conditions are met, the segments are merged. The shorter segments are deleted, and the longer segments are retained. Finally, the segments that are wrongly segmented are merged. For the wrong segment, the method is as follows. The distance between two segments is less than the merging threshold, and the slope difference between the two segments is less than the slope threshold. If the conditions are met, merge segments. Take the two fastest endpoints of two line segments as the two endpoints of the merging line segments. Generate a merging line segment and delete the two original line segments. And step 4, repeat step 2 and step 3 for the line segment set until the set is no longer updated, which means that the line segment merging is completed. The results are as following. After above step, the line segment in the set can be represented in the form of the triangle in the lignature image to a certain extent. And the next, we need to find the appropriate line segment apart from the set. The steps are as follows. Firstly, classify the line segments in the set according to the slope. Line segments with positive slope from set 1, line segments with negative slope from set 2. The process are as follows. Where function endpoint distance line 1, line 2 calculate the return, the minimum distance between two endpoints of line 1 and the two endpoints of line 2. The results are as following. in order to verify the performance of the proposed method. This paper used the self-built academic literature triangle coordinate diagrams dataset for experiments. We searched the open academic literature dataset for keywords such as sandstones and province. After major adjustment, 43 literature contains triangle coordinate diagrams was selected and constructed into the self-built dataset for this paper. The experiment used the method in this paper to locate the triangle coordinate diagram in the dataset. The results are given as a triangle box on the rounded page. If no triangle coordinate diagram is found, no box is given in the corresponding area. The result of the experiment is checked manually. For the result of the triangle coordinate diagram, there are 4 possible kinds of a result: correct, wrong, missing, and extra. Through experiments and manual verification, there are 112 triangle coordinate diagrams in 47 pages. The method in this paper given 76 diagrams position result, and of which 75 are correct and 37 are missing. 1 is extra and no wrong. The position root of the method is 98.68%, and the record rate is 90.98%. Experimental result shows that this method has high precision but low record. The higher precision is attributed to the strict decision rules of the method. However, because of this, the strict decision rules have a certain impact on the record rate. For example, when the data points are close to the form of triangle coordinate diagram, when detecting the line segment of the form, because of the extents of the data points on the form line segment may be recognized as a multi-segment line segment or not a segment, which will have an impact on the record rate. This paper solves the problem of academic literature triangle coordinate diagram localization. A new triangle coordinate diagram localization method is established by line segment detection and line segment merging. Compared with the method based on the coding information in the PDF format literature, this method can be solved the problem of literature diagram localization in the scanning format of image. In this method, after detecting the position of line segments by line segment detection, the line segments are merged, so the wrong detection of line segment group can be avoided. Nevertheless, there are still some improvements needed for this method. In the line segment merging step, it is necessary to manually set a appropriate threshold as the base for the line segment merging or not. When judging the triangle coordinate diagram, the mode adopts the rules set manually to filter the line segments. That means when dealing with the other type of triangle coordinate diagram, it is needed to be set according to the specific condition of those diagrams. And it is one of the problems to be solved in the follow-up. This is the introduction of my work. Thank you.